Hi, Josh.
Can you hear me, Meredith?
Yep.
Cool.
Mm. Oops, wrong folder. All right, how are you all doing?
Pretty good. It's a beautiful day. How about you?
Oh, it's nice. Well, I got out yesterday and went for a bike ride. It was really nice to go out and saw quite a few other people out and about yesterday because it was a really nice day yesterday. I had to get away from my computer. I was at it for like 8 hours straight. So I posted the lecture for this week on stairs, and then I went to look to see how folks were doing with the the little homework lessons that are from the lesson plan. And I have some feedback and some stuff to talk about the wall sections. That's on my agenda for today, and then I figured that you all might have some questions as well. And I think, yeah, now I've figured it out. I got these meetings being recorded right at the beginning, so I don't forget to do it. So we are recording right now. So I guess I'll get started with the things that I wanted to touch base on. Before I do that, everybody that's in, I just want to make sure everybody can hear me. Anybody having technical issues? If you are, just use the chat button to let me know. Okay, good. So I'm going to go ahead and share my screen. There we go. And I want to share the Josephine project with you all, because I want to go over some things having to do with door and window sizes, determining that header depth, and then there are really kind of two ways to go about getting the wall height for the Josephine, because we have a garage with an overhead door that's pretty big. But when we look at how this is constructed, the slab for the garage is quite a bit lower than the house. So there's a little bit of coordination that has to happen to get these roof lines to all line up. If we want all those roof lines to line up all the way around the building, we do have to take into consideration, what does this wall height have to be as a minimum? We also have to compare that to what this wall height has to be as a minimum, and then see how do we make all those roof lines line up? So that's the kind of stuff that I wanted to talk about today, is that coordination. So I figured you needed to see the project in full 3D mode so you can see what we're trying to do is make these roof lines all line up. Does that make sense with everyone? So Nick, I'm going to use you as an example in particular, if you don't mind.
That's fine.
All right. So what you provided your answers for your wall section, which were correct, because I didn't say, you know, ignore the garage or anything, but you put your answers in based off of the garage doors being the tallest and widest opening. Oh, I mean, a few more people chiming in here. And that is correct in coming up with the wall height over the garage. So I'm going to kind of go over both of these areas. We have to kind of do it again though in the house. We have to find out what's that wall height in the house, because the floor is raised in the house, and we're just trying to make all of these levels work with each other based off of what we came up with for the dimensions and the changes in level that we have in the foundation section. So I want to go back to that foundation plan, and we have our first floor that I'm going to be using as reference. That first floor is going to be like the baseline. Think of it as the baseline for what we'll use for the entire project. From the first floor, I'll put the actual dimension here that I ended up putting in. I ended up putting the slab for that mudroom area at 1 foot 2 1/4 inches down, so that it matched the height of the top of the concrete wall. So that slab's being poured right at the top of the concrete wall. But I just put in here a variable just to give a little bit of wiggle room for somebody who might be placing the slab. If they end up placing it a little bit lower than that, 15 inches would be the maximum. And then we have the 10-inch difference between where the slab is in the mudroom area and then where the garage is, okay? So yeah, I'm not sure where this 8.5 inches is coming from. I'm going to delete that. So that's the change in elevations that we have from the floors, okay? So now we're going to go look at the section view that I have, and this is the section through the garage at the garage doors. And Nick, you may have used some different numbers, but I told you, I think, in feedback, I'm not sure if you guys are seeing the feedback or not. Some of you, I think, are not. So I'm going to try to come up with a different way to give you guys feedback from the quizzes that are online. But that rough opening is usually about the same size as the overhead door when you're dealing with overhead doors, because the way that they're installed is the overhead door size is the rough opening size, and then the door is installed just on the inside. It bypasses the inside face of the wall. And, and then what happens is you frame out everything around that door so that that gets framed in and trimmed and everything and looks nice. So this rough opening should say 7 feet. I was wrestling with AutoCAD, with Revit today, and I couldn't get all the head heights to work exactly the way I wanted, but let's make that, let's pretend that that's actually 7 feet. Whoops, I'm going to overwrite it. Yep, okay. Because I want us to all use the same dimensions and I don't want it to be confusing. So there's our rough opening of 7 feet. If we take that 7 foot dimension, that's where the bottom of the headers are going to go. And then we have the depth of the headers. I put 3 2x12s over my overhead door, considering the snow load for the roof. That this is a hip roof, so all 4 sides of the garage need to have a header over any kind of opening that we have. And then this distance that I have here seems arbitrary, but what I did was I made sure that the wall height for the garage, or where that top of wall is, matches the roof height for the house. So that's where that number is coming from. And that 9 feet is not 9 feet from this garage slab, as you can see. It's 9 feet from this finished floor in the house. So what that dimension comes out to be in the garage is 10 feet 8 1/4 to make that wall height match. Okay, so I should be able to get out of this, whatever the resulting dimension here between the cripples should end up adding up to this number when I add that minimum wall height to this, and 2 feet 6 inches, then I should end up with this number. Okay, and I'm going to stop there and see if I've lost anybody or if it makes sense so far.
I'll be honest, my kids came in and started telling me jokes, so I'm going to have to listen to the beginning of this video again.
Okay. All right. Yeah, I know distractions are difficult right now. All right. Well, we'll take a look at that then. Actually, the sill height is supposed to be at 0. Well, anyway. So anyway, the height here that we should end up getting, if we were to do the math, let's just kind of quickly do the math together, and then we'll see if it comes out right. If it's 7 feet is the height of the door, plus we've got the 2x12s, which is 11.25 inches, plus 3 inches. Whoops, I have to put 84 for 7 feet. 84 plus 11.25 plus 3 is 98.25. Divide that by 12. The minimum wall height would have to be 8.19 decimal feet, as I have to use decimal feet here with that calculation. So we're looking at, what is it, 0.1875 decimal feet. So minus 8 times 12 is about 2 1/4. So it's 8 feet 2 1/4 inches is what we would have to have for a minimum wall height to fit that door, that header, and the 2 top plates. And that probably still wouldn't be enough in the garage for this overhead door to pass. So the rough opening of the door is one of the things that gets taken into consideration here. But then I also need to probably have about 1 foot to 1.5 foot of space for where this garage door rolls over, or for the housing for the motor if there's things like that. So there's a little bit more to it with the overhead door that I wanted to make sure I went over, because I realized that I hadn't with overhead doors. So that being said, we have more than enough space in this wall. And now what we're trying to do is design this house so that top of wall that we have here in the garage is always going to match the roof, so our roof lines stay the same around the whole project. So do you see where that part of it, we need to know like both of those pieces to be able to make that work. So somebody remember that 8 feet 2 1/4 in the garage that we need for the overhead door height, if you will. And we're going to go back over to the house now, and we have a 9-foot ceiling. And what I have in here, if I were to do a dimension from the subfloor, because that's where the bottom of the wall is, to the top of the header, it ends up being 7 feet 8 1/2 inches, and that would be the 6 feet 10 1/2 plus 11 or 11 1/4. And then if I add the 3 inches to that, I'm going to get, let's move that all the way up to here. I have 9 feet 3/4 inches as a top of wall to rough floor, subfloor dimension. If I take that number and subtract the actual wall height this needs to be, and this wall height needs to be 6 feet 10 1/2 inches plus 11 1/4 plus 3 inches. If I take that number, that ends up be 7 feet 10 3/4 inches, then I should end up with the cripple height here. But let's see what happens if I drop this wall height all the way down to the lowest it can go. And I can do that by clicking on this and putting in that number of my minimum wall height. And if I do that, I'm going to just ignore the warnings it gives me. Now because I have my garage wall or roof locked to the same dimension, our new dimension for our wall height over here, at a minimum, if we wanted it to be coordinated with the main house, at a minimum, this wall height in the garage would have to be 9 feet 7 inches. So do you see how, even though we came up with the wall height for the garage, that was the minimum wall height, if the garage was standalone, it would not be adequate for us to include the height we need to have to match the roof lines for the house. And that's more or less what I was getting at. And that was the other extra ball of wax that I couldn't really go through without you guys being able to visually see it. So now the wall height in the house is at its lowest it can possibly be, because if I put all these things back where they're supposed to be, let's move this down here so the top plate's resting right on top of the 2 headers. That's the smallest wall height that I can have to fit what I need into my wall. Some of you might have 2x12s in here. If you have 2x12s, then your number would be 8 feet 0 3/4 inches when you add up those dimensions. All right, so I want to see if I got any questions based off of that, or if I got any comments or need to clarify anything. Nobody's got anything to contribute or ask? Does that mean you understand it, or you're not sure what to ask?
I think I understand it.
Okay. Now, in this project, because of the format we had to change for how you guys are delivering your information, I guess the good news for you is I don't want you to worry about this half of the house. Let's pretend like that's already designed, because whatever you set your wall height to here based off of what you're doing in the main part of the house, this wall height here in the main part of the house is always going to be more than enough space that we need for the garage. Does that make sense to everyone as far as height goes?
Yep.
Okay, so this is where we want to concentrate our minimum wall height that we need to know it, just so that we don't design something that's shorter than it's supposed to be. Can I ask, let me get some feedback from you all about what kinds of windows and doors that you've selected. I know that we haven't really talked about windows and doors yet, but I wanted you to kind of think about, what would look nice here, or how, envisioning what this house might look like. So that's the other reason why I wanted to show you a house that did have some, window and door stuff placed so that you could see what it could look like, right? So what I decided to do was go with some double windows in the front. And then I'm figuring this area right here is going to be about where the kitchen's going to be, So I figured that was going to be a casement window. These 2 windows that I got here, tucked up in here, are to add some natural light into that stairwell area. And then I figured I'd have a bathroom between 2 bedrooms or something like that on that side. So I just was kind of making things up, and that's fine. You guys can do that as well. When you get into designing the actual layout of this area here, when we talk about, after we have a chance to talk about kitchens and bathrooms, you're going to be able to be a little bit more informed about what you're going to do exactly with this layout. So we are putting a little bit the cart before the horse with these windows. I'm not too concerned about where you're placing the windows, however, because those might move around once you start designing your floor plan. But I bet you can kind of consider what types of windows you might want to use, and whether or not they're going to be wider than your doors or things like that. And even if you're in a ballpark for what's the widest opening you have, let's say you're picking out some windows and you're not sure if you want them to be, a bay window or a 2 double hung windows. whatever one's the largest one, pick that one, and that way your header has been designed for what you could possibly be the largest or widest opening, okay? So if any of you are having trouble with how do I come up with that window width, that's what I want you to do, is just kind of imagine what these windows could be configured like, okay?
Mhm.
All right.
I have a question.
Yep. Who's?
So I think I'm a little bit behind in getting my wall section done. And are we supposed to be doing that on the same paper that we've been doing the foundation section and the floor framing section? Because I don't know how much room I have to like move up.
No, yeah. If you're talking about the sheet that had the original foundation plan and section on, you don't really have any more room to put anything there. So I had given you if you're doing this by hand, Scylla, is it Scylla? Yeah. Then you're fine putting it on an A-size sheet of paper, and you can use the grid paper that I gave originally. That's fine too, so that way you know that you're drawing it to some kind of scale. Normally, you know, we would be formatting this on the same size sheets of paper, and each view would be coordinated within the sheet set, but I'm really having to be creative that way with how people can submit stuff. So you're okay doing a, we'll call it a wall section study, you know, a sketch that shows what are the components in that wall. You know, maybe imagine cutting through the door or a window to give you an idea of where's the header in that door, you know, where is everything when I cut through that door or window in that wall section, okay? And you guys have those examples too of what those wall sections look like. There's a really good example of it in the shared drive space that we have. I have two examples. This one here shows what does it look like cutting through a door, and where does the insulation go. And then you've got one on the second floor that shows what it looks like cutting through a window. We only need to worry about the first floor, so I don't care whether you cut through a door or a window, but it would make sense to do that because then it's going to make sense why, you know, where those headers go when you do that. Okay?
I have two questions.
Okay.
One, were you just showing us the files that you were talking about? Because I didn't see anything on the screen. And I think I misunderstood this wall thing entirely. Are we just doing a section?
Yes, you're going to do a section that represents what would a wall section, a typical wall section look like through the Josephine project. And the Josephine project is a single story. So you're going to cut through from the top of the foundation wall to where the roof would hit the top of the wall. And we're going to add the roof detail to that wall section later. It might have to be on a separate page though. We might run out of room. So I'm expecting to see you draw a wall section to where the top of the wall is here. But Tori, you're saying you can't see my screen right now?
I see your screen, but I didn't see anything that looked like a wall section. I mean, I'm seeing a top view of Josephine, the foundation plan.
Yeah,
Right now,
I see
you're
the
not
Revit.
seeing a wall.
I see your Revit plan.
Yeah, I'm just seeing Revit.
Oh, I'm
Yeah.
sorry. You know what it is I attached it to a, and this is the thing about this is this is what I got to do here. Does that look better?
Yes.
Okay, there we go. So yeah, I attached it to the, I attached the share screen to the application rather than my my computer screen. Sorry about that. But you were able to see all the Josephine stuff, correct?
Yes.
Okay, all right, yeah, so this is a typical wall section and it's located, if I back up a little bit, you guys all have access to this shared drive here where it's in the shared drive under the student R drive resources that I shared with you, 165. And everything I've been referencing is in assignments and handouts. And this in particular is under wall framing. You've got a whole bunch of resources here that I used in that wall lecture. And the one that I just showed you, which was the solid blocking section view, is a good reference for what kind of call outs go in the wall section and what that looks like. So I'm looking for a wall section that's basically from where these two top plates are down to where the top of the concrete wall is, that represents what is happening in the Josephine. So I'm going to use Sarah as an example. Sarah.
Yeah.
Hi. Have
Hi.
you decided you're going to go with those I-joists like we talked about via email?
No, I just went with lumber.
Okay.
I thought it'd be easier.
Okay. Well, Sarah and I were chatting on email about, she asked a few questions about, can I use I-joists and not have to use lally columns at all? And I said, sure, as long as you can find a solution to those, you know, the floor framing that includes something that will work with, let me just make sure I'm in the right floor framing thing. So I'm going to go to the span tables real quick. Engineered lumber, if we look at I-joists, I'm looking for something that can span 28 feet. If I do that, I think I'm probably in the 16 inch, yeah, let's use 16 inch deep 360s can span 29 feet at 16 inches on center. So guess what that does to this wall section, right? Can you guys tell me or imagine what that does to that wall section? Oops, let me bring that back. I'm just looking for the wall section, bring it back up again before I, so right down here, what that does is this is from the top of the mud sill to that finished floor would be 16 inches, then 3/4 and 3/4, right?
Yep.
So this is why I wanted to make sure you all realize you're not just going to copy this, you're going to think about what is going to work for this Josephine project based off of what you came up with for framing. And then you all are going to come up with a wall section that works based off of the, you know, doors and windows that you think you might be using for the Josephine project. You might pick out a header size that's a little bit too big for what you need when you finally finish your project, but that's better than picking out one that's not big enough, right?
Mm-hmm.
Okay.
I have a question about the span charts for the headers.
Yep.
So for like the homework assignment, we used the book.
Yep.
Going forward, you don't want us to do that, right? Just use
Well,
the.
I wanted to start off using the book because it's so simple to read it, right?
Right.
But in reality, when I'm picking out a header size here, I need to take into consideration the weight of the entire structure. So this
Right.
header, for instance, is holding up this whole second floor, plus it's holding up a roof. When you consider the load that's being applied on the roof, that's a 50-pound snow load on the roof. And then we have a full second floor, and then the header's holding all that up. So you just have to make sure you're reading the header and girder spans using that chart is more conservative in that you're going to end up having a header that's probably built up a little bit more, just a little, it's a little bit more over engineered than you might need, but you're definitely going to have something that you know will work. So those girder and the same chart we used for the picking out the beam in the middle of the house is the same one you're going to use for the headers. So let's zoom in on this and we'll take a look at it. And I want to explain a few things here too. When you're picking out, if you're trying to pick out a header size for the Josephine, for instance, if you had absolutely no walls at all in your first floor, you walked in and it was just wide open space, then that means that the header is on either side of those exterior walls is having to support half of the full building width. Does that make sense to everyone? Because that
Yep.
means I have no bearing walls at all in my floor. Well, what's probably going to happen, and I'll bring up the Josephine here for a second. I have to change my share settings, don't I? How can I just hit share screen, for heaven's sakes? Well, oh well, there's, all right, so can everybody see the Josephine again?
Mm-hmm.
Okay, so more likely than not, and I'm just gonna kind of throw in some walls here. More likely than not, we're going to have maybe like a bedrooms and bathroom over here on this side, and maybe this whole side is all open. If that is the case, then our true dimension that we want to be looking at to come up with that header size is how far that header, this header, if I'm designing it over this window, for instance, it has to be able to support half of the span of all the floor joists, or the ceiling joists rather, that are resting on it. And half of that span ends up being 17 feet. We'll call it 18 feet to make it conservative, okay? So that number is the number I'd have to use if I had walls in here. If I didn't have any walls in here, then I'd have to use the full 28 feet for width to come up with that header size. Okay, so I'm gonna keep going here. Bear with me. Let me go back to the span charts. So now that we know that, the lowest number I have to look at is 20 feet, right? Well, that also is just building in some extra strength in that wall header. If you know you're looking up something for 20 feet, you know it certainly is going to be able to be used for about 17 plus feet, right? This header is only supporting a roof and a ceiling in the Josephine, correct?
Mm-hmm.
So I can look down, and let's say I have a window that is 8 feet 6 inches wide. So if I have a window that's 8 feet 6 inches wide, I've got to use these 3 2x10s because that is the first number I come to that exceeds that 8 feet 6 inches for width.
Mm-hmm.
So those 3 2x10s would be what I'd have to design for the biggest header I would need for my project. Okay? If I only have windows that are only about 4 feet wide, I could use 2 2x6s and be fine for all the headers. If all my doors and windows were no more than 4 feet wide, then there are my header sizes right there. Okay? All right, so let me go back to the, I guess.
Hey, Meredith.
Yep.
I had a question about the floor framing. I think last week I talked to you about using an I-joist to get a big span, a big opening in the basement, and but I was thinking about using a beam in there, and we talked about doing like the double stack thing with I-joists resting on a nominal wood beam. Could I use and we talked about it because the engineered wood would restrict and contract differently than the nominal wood. Could I use a microlam beam and have it be in line with the I-joist so that the floor framing isn't so big?
Absolutely. Yes.
Okay.
Yes. That's exactly what you would do. So all of the microlam stuff and the glue laminate, there's the engineered lumber. Let me just hit stop share for right now. So all of the engineered lumber is meant to be able to work together because it is all manufactured in the same method. It's all glue laminated in some way, wood or fibers. Let me just check somebody. Okay. Yep. So that's fine. You can do that. And so you're just going to look up your beam size in that microlam PDF that I gave you. And then you can look up the I-joist size based off of the spacing, or the spacing would be determined based off where you decide to put that beam. Okay.
All right, cool. Thanks.
Mm-hmm. Anybody else have any other questions or specifics about the homework? Anything at all? You can, this is your opportunity to do that.
I've got a question.
Okay.
What if I wanted to do something crazy and like do bay windows or something? How would that change? I'm just going to let you answer. I have a feeling you have more information than I can come up with for my question.
So you're thinking you want to use some bay windows, Tori?
I'd like to think and look into the possibility. I'm
Okay.
quite in love with them.
How do I just hit share everything, for heaven's sakes? Maybe I just do it like that. If I flip now, can you guys see everything if I flip?
Yep.
Okay, perfect. So I'm going to, because it's fun, we're going to go to Anderson window and look at bay windows. And all I'm going to do, the reason I'm going to do this is I want us to find out, bay or bow windows, what is the widest or rough opening for the bay window? What does it need to be? Okay. And I want to see the catalog for it. So let's pick this one right here, I guess, view details. And bay window comes as one window unit. So that bay window unit, if we look at our specifications, size right here, and look at our size chart, let's see if this is going to give me what I want. Standard size chart. There's always many, many layers to these things, unfortunately. All right, so now we're in somewhere where we can get some critical information. And what I'm looking for is what's the rough opening. And you've got rough opening, that's the rough opening sizes here for our width. And that's the only one you're really interested in right now, Tori. So you can see that the sizes, the general sizes that they come in, are based off of the 3 window units they're putting together to create that bay window factory mulled unit. So regardless of what you pick out for a window type, it doesn't matter that the bay window sticks out beyond the wall. We just have to make a hole in the wall that matches the rough opening of this so we can install it. Okay? So
Okay,
really
so the bay window, bay window is fairly self-contained. It's just a matter, like, because I wasn't sure that
it comes as
comes with
one
a roof
window
to build.
unit. Yeah, it's not installed as 3 separate windows. So it comes all put together in factory mold, and then it gets installed in the window. Usually you do have to design a little roof to go over it or something, or it comes with it might come with the manufacturer's little roof system that you put over the window if it sticks out beyond your overhang. But for now, when you're cutting your section for your wall section, it is it's really most important what's that width that we're looking at, right? So
okay, so it doesn't necessarily change my header other than making sure it can span the width of the window.
Right, and I actually did use a bay window as an example in my Google slide for the one of the wall examples that I did, because I did a bay window here in this example project and showed, okay, there's where the header would go. But you see how the bay window it's all one unit that would be just placed into that wall opening.
Yeah.
And we came up with a header size for it. And then that's kind of what you would see in section. I'm not really getting into all the detail for all the little pieces and parts that are actually in the bay window. But you can download that stuff from the Anderson window or whatever manufacturer specifications and detailing. But that's not really important because we're not building this window. We're just having to install it. So I need to make sure I tell my framers what does that number need to be in order to get this window to install in that wall, right?
Okay, thank you.
Yep.
When let's say a triple window, and I know that they have triple units. Are you sometimes not deciding to do like windows instead so you can have jack and inside?
Josh, for some reason, I'm getting a lot of reverb on your question and I couldn't hear all of it. Could you try that again?
I think if he turns down the speakers, it should work because his mic is picking up the sound coming out of the computer.
Yeah.
And yeah.
This happened before.
Yeah. I'm getting a real echo from you, so it's hard for me to hear what your question is. You can also type it in the chat, and
Is it any better?
not too much. Not too much better. No, now I can barely hear you.
Yeah, you don't want to turn down the mic, just the speakers. We're getting the audio version of looking into two mirrors at the same time.
Yeah. I'll just chat.
Yeah, add your chat, and I'll take a look at it right now. Oh, while he's doing that, Scylla, I sent you, Scylla, are you still there?
Yes.
Okay, I sent you back a comment on your, because you sent me a comment on the questions for the wall sections. I'm still trying to figure out how to get the comments to show up on your guys' end, and I thought that by reworking the exam, it gives you a chance to go back and read my comments, but it turns out it turns off all my comments when I do that. So this time I graded your exam and actually put the grade in and gave you the feedback, but because I have it set to unlimited chances, you should be able to go in and now read my comments and then make those changes. Okay?
Mm-hmm.
And please let me know if you can't, and then I will.
I did see the feedback. I had to scroll all the way down, and then
Okay.
there was an extra, it was like a list of the questions with a green or red check next to each one, showing how much, and I could click on your comments. So I'll redo
Good.
that.
All right. So so I got the question from Josh now. He was asking a triple unit window versus a 3 individual units. That is a good question. Like, how do you decide whether or not it's going to be, counted as 1 window unit or separate units? So I figured I'll zoom in on this to show you. Do you see how that is reading as a single window unit? There's no wall space in between these two mulled windows. If I were to take these 2 windows and just put them really close together, but there's still a little bit of wall space between them, then those are still going to be considered 2 separate units because I can fit some framing in between those units. If you decide to draw, if you're doing this in AutoCAD or by hand, and you draw these windows so that there's absolutely no wall in between the windows, it's better to consider that all one big wide opening because you cannot get any framing in between those windows the way you've drawn them. Okay, so if you draw the windows so that there's a little bit of wall between the windows, consider them 2 separate units. Whoops. Let me just see. Josh, did that answer your question? Let me know in the chat. All right. So here we are in the stairs week, and that's what I posted yesterday. So on Thursday, it would be great if everyone has had a chance to look at the stairs. I've got a lecture, and then I have the shared Google slide again, and then I also have a video that shows you how to actually draw out stairs in AutoCAD. I just used AutoCAD because it's the easiest thing. It's the most like drawing it by hand as well. I kind of lay it out using offset, trim, and extend so that you can see how you would lay out a set of stairs based off of your calculations. So that's what you're going to want to take a look at. The only assignment for the stairs week is to just be able to do the calculations and show me your calculations and enter them into the coursework portal, a workbook, if you will, or quiz that we have once a week. There is no drawing associated with it because we just don't have time to do a full stair section this semester. And I have the stair section already done for you. So when we look at that section view, it's going to be different if somebody decides to do a much thicker floor framing here, then that would raise that stair. But what you can do is you can come up with how many risers and treads you would have based off of your actual dimension from the finished floor to slab. But you don't have to worry about changing that in your project for this semester. But I do want everybody to know how to calculate the stair run to tread and riser count and riser height, and have an understanding of what the compliancy rules are for stairs. So all of that information is in this week's lecture. And did everybody receive that email, I hope?
Mm-hmm.
Okay. So I also am posting all this stuff. Let me just show you that I've got it also on the class portal. So if you lose track of where that email is or something like that, if you go to 165 and go to videos, right at the top, I started to put remote learning lectures and then whatever the topic is. So you have the previous floor framing lecture and Google Slide, wall sections, lectures in Google Slide here. Oh, I guess I didn't put the lecture in there. Sorry about that. And then this is the stairs, has the lecture, Google Slides, and then the reference folder, and then how to draw stairs in section. So my bad for not putting that wall section lecture in there. I thought I had, so I'll get that in there. But most of the reference material will be put right here, in addition to me emailing it to you so you know that it's up.
Hey, Meredith.
Yep.
So I watched the lectures already, and I was doing out some of the calculations for stairs.
Yep.
And when I was doing out the one for my risers, I got like a funky number. It was like 7.2857. Is it okay to leave that in decimal feet, or is there any way I could put it into fractions? Because it's weird.
So this is what you ended up with, 7.2857?
Yeah, for every riser, yeah.
So to turn it into a fraction, really more often, well, I'm going to be honest with you, no builder is going to deal with a 32nd of an inch. they will be fine with 16ths, but you know, so I usually round this to the nearest 16th. So let's subtract the 7 inches from it and then multiply that times 16. And I would round this up because that's 4.5/16. So round that up to 5.56. So it would be 7 5/16 that you'd have for a riser height.
Okay, and that's gonna cause some variance in like the top or bottom stair, right?
It is, but you're allowed up to 3/8 of an inch difference from the tallest step to the shortest step. Can be up to 3/8 of an inch different.
Okay, I'll give it a shot.
So I think that's pretty close. That's pretty close to what you need right there, that it will work. Are you, where are you, or if you draw this in AutoCAD, you'll see how I use divide to kind of automatically have the risers be divided perfectly. It goes out this many decimal places. But when I actually put my dimension on it, I round all my dimensions to the nearest 16th, and it gives me those dimensions automatically. Okay.
Okay, cool.
Yep.
Thank you.
Yep. And I just wanted to show you too what this looks like in framing with the stair opening. I think I did this the last class, but this is where those stairs would go. This is the opening for those stairs. That lally column is holding up the corner of the floor right here. We got two floor joists that are doubled up together here and here to carry that weight for the header here and here. And you see how I did not have to have the top of my stairs attached to that middle header or middle beam. It's okay for me to you know, move that over like that. If I wanted to try to design this so this was a straight set of stairs, I could probably fit it in here, but then I wouldn't be able to get, you know, get the door in here based off of where the mudroom and the mudroom is relative to the house position. So this is a perfectly fine way to do it. So I still kept my beam in the center and then just, moved the head of my stairs where I needed it to be to create that L-shaped opening in the corner. And for your I-joists, Nick, these would be maybe, I don't know if you need to double up the I-joists in your scenario or if they would just be single, but if you look at that PDF, there's a lot of pictures that show you how the framing is configured in different scenarios. There's a lot of good 3D pictures that show you those connections. And in some places they would use just a laminated board instead of headers. So check that out if you're using the I-joist for your framing, okay? Just so that you know, you're not detailing that. All right, anything else I can help with today?
Meredith, I'm just testing my sound. Is this
Yeah,
better?
much better, much better.
I had
It's
external speakers. That was the problem.
okay, that was it. Yeah, because you sounded okay when you first came in, and then when you were asking that question, it was like a reverb, like you couldn't believe it was echoing for ages.
I use an Apple computer and I go to boot camp. So when I'm doing it with my other friends, it's in Apple. This is now in Microsoft, and so changing things over is not as great.
But did you get your question answered? Did I answer? Did I get at what you meant?
It was basically like, I think that you can make it so you have shorter spans if you use individual windows, but a lot of times they'll sell those multi, and that would be just cheaper, or is that just going to be just a cleaner look? That's what people use it for.
I think it's the kind of view you want to have. When you put all your window units together, you get more of an expansive view because you have a lot less of the wall interrupting that view. But when the wider you get with a header, with a window, the bigger the header needs to be, and you can get to a point where you have to put a pretty good size beam up there in order to have that clear space. These modern houses with all of the floor to ceiling windows, those are curtain walls, those aren't windows, so they have structural mullions in them.
Mm-hmm.
And then there's usually a pretty good sized header over those to allow for that curtain wall to just be able to wrap around the exterior structure. And the curtain wall itself is not structural, it's just kind of hanging out between those structural elements.
Right. One thing I also was struggling to import like Marvin or Anderson multi-unit windows into Revit. I was struggling because they don't give you like the size charts for each one. Or they don't give you each window that they offer. It was like one window that I couldn't figure out how to adjust.
You know what? We should probably have a side chat about that, because I know I have been able to you have to bring in, when you bring the RFA file in there, those zipped files come with the TXT catalog files too. And that's where you get all the different sizes.
Okay. That was kind of depending on what I was going to use, either Marvin or Anderson. And it was like, I couldn't get either one to work.
Yeah, no, if you want to stick around at the end there, I can show you how to do that.
Okay.
Okay. Who did I not hear from? Carly, how are you doing? Are you still there?
Yeah.
Yep.
I think good.
Everything's going well. Yeah, I think I gave you you gave me an email recently with your most recent foundation foundation wall section, right?
Yeah, that was just the first one that we had done.
Right. And so what you're doing with that is all you're doing is adding that framing to it, the floor framing information, and that floor framing happens just over the house portion of that foundation wall, and then, pardon me, over the deck there in the front, right?
Yeah. Yeah.
Okay. Well, good. Then sounds like you know what you're doing. All right.
Well, so the A size papers that you're talking about,
Yep.
That's not due tonight, right? No,
check in your this thing right here tells you everything that's due either online. The stuff in yellow are things that are weekly activities that I'm having you do online that are these little worksheet quizzes, if you will. And then down below, it might say, like, let me use this page right here that talks about roofs. Down at the bottom, it says final project homework. And that stuff, anything that says final project homework, it's ultimately due at the end of the semester. But if you want me to review it, do exactly what you did. Either email it to me and show me a picture of where you are so far, or you can post your stuff also, remember, on that forum, and I can give you feedback there too. Either way, whatever you're more comfortable with.
Okay.
Okay?
Yep.
David, how you doing?
I'm doing good. I'm finishing up my floor framing for the Josephine.
Okay. If you could send me a picture of it, why don't you do this? Send me a picture of it where you're at today, even if you're not quite done with it, and that way I can at least let you know, you're on the right track, or add these other call outs or whatever. Okay?
Yeah.
All right. Perfect.
But I'm still following along though and everything in
Good.
class. I've just been super busy with work lately and everything. My boss
Yeah.
has been wanting me to help him out more and everything.
Oh, I know. Everybody's lives are upside down. And at this point right now too, if you can work, you got to work, right? Like there's a lot of people that are out of work,
Yeah,
and
exactly.
so, yep. No, I get it. That's why I'm trying to be as creative as possible with this stuff. Yep. Well, good. I just wanted to check in with everyone that I didn't hear from today, and just see where you were at. And I encourage you to go ahead and send me anything that you've got so far, because I'm happy to give you that feedback. Okay. All right. So if you haven't done so already, go ahead and take a look at those stair videos when you get a chance, and then we'll meet again on Thursday. And we'll probably have some conversations about stairs then. Okay?
Could you remind me again, like, what is like a good rule to follow for like the spacing of like lolly columns?
Well, it depends on what you're using for a beam.
Uh-huh.
So if I've got, let's take the biggest beam that we would put together, 4 2x12s for a built-up nominal wood lumber.
Uh-huh.
I can probably put those lally columns further apart, right? Because it's bigger. But if I've got only 2 2x6s as a beam, then I have to put those lally columns a lot further together. And you get that by looking at that beam span chart. So I initially gave you guys the 8 feet as a maximum span between lally columns before we really had a chance to talk about framing, because we were talking about foundations at the time and what is a lally column and so on. But now you know a little bit more, and you know that you can go to those span charts. And I don't think I ever saw anything on the span charts that was much more than about, just about 10 feet is the max. And that was in a very specific situation where it was only holding up one floor, and the building width isn't very wide, and stuff like that. So go back to those, in particular, the beam span charts. Look under your Josephine house width, and look to see what's the furthest distance apart I'm allowed to make these lally columns. You'll see the number, and then you go across and see, okay, that means I have to use 4 2x12s to do that. Okay.
Oh, okay.
Yeah.
Thank
you. You'll see there's some. I think the widest. Let me just to make sure that. Oh, because I think I've got the beam. Yeah, I still have it open. Perfect. So you got 28-foot wide Josephine, right?
Yep.
And
right
if I'm holding up a roof, a ceiling, and one center bearing floor, so you look at, according to this, I really can't put those lally columns any further apart than 9 feet 3 inches, right?
Oh yeah.
And then I have to use 4 2x12s if I do that. If I decided to make a lally column every 2 feet 5 inches, I could make that beam only two 2x4s, which would be kind of silly, That'd be
Uh-huh.
defeating the purpose of these lolly columns. And if I did that, I might as well just pour another foundation wall and use that as my, you know, right? So, so when you look at these numbers, those are your numbers that you can work with, and that, you know, so if you're trying to, you know, drop a lolly column or get them as far apart as possible, you want to look at the biggest number you can use here. But see up here, I can actually push those lolly columns apart up to 10 feet.
Yeah, further if
Because
you
it's
use
only
4 2 by
supporting a
12.
roof and a ceiling, exactly. Yep.
Yeah.
Okay.
What does the NJD mean? Is that like number of joists?
Number of jack studs.
Jack studs?
So this, you remember, this is for girder and header spans.
Uh-huh.
So we're reading it right now for a girder, and that also tells you too that the beam itself needs 3 inches of a shelf for it to rest on. It's not enough for it to be 1.5, but 2 jack studs are the number of jack studs you need if you had an opening that was that wide, supporting half of the 26 feet. It would need to have 2 jack studs on both sides of it.
Oh, okay.
Doubled up, in other words. So that's what NJD stands for, is number of jack studs.
Uh-huh. Thank you.
Yep. And then, yeah, you can see it down here too. It explains what that is. Okay.
Mm-hmm.
All right. I'm done with what I wanted to cover, and touched on the things that I wanted to give you feedback on. So if everybody else has got their questions answered, we're all set.
I'm all set.
Okay.
Y'all have a good day.
You too. I'll see you Thursday, or see you Thursday. Yeah, you'll see me Thursday. All right.
Well, yeah, I'm all set. I'm gonna
Okay,
print
David.
out. I'm gonna print out that chart and keep working on my Josephine drawing.
Okay, good.
Bye.
Bye. All right, I'm going to stop recording now then.